Hello everyone. Today is day 20 of coding every day. Today is a Tuesday. It's February 4th, 2025. So today I'm going to be looking at combination sum 2. So I don't remember if I did it in one of the videos or not. But I did do combination sum 1. Which I kind of forgot how to do because backtracking is a little new to me. So let's see if I can do combination sum 2. So you're given an array of integers candidates which may contain duplicates and a target integer target. Your task is to return a list of all unique combinations of candidates where the chosen number sums the target. Okay, so that's combination sum. Each element from candidates may be chosen at most once within a combination. Okay, so this is combination sum, and this is combination sum 2, I guess. So if we draw it out, we can choose each one. So okay, so your starting point, you start at 0, and then you can, for every path, let's just say that but there's several twos. Okay, so if we say 9, 2, 2, 4, 6, 1, 5. So if we have 0, we can go to 9, we can go to 2, we can go to 2, we can go to 4, we can go to 6, 1, or 5. And it also has like a new set, I guess. So for instance, this 2, or I guess 9, now we have 2, 2, 4, 6, 1, 5. So at every step you reduce you get rid of the index of whichever one you chose. Okay, so let me look at I just want to see what I called the function for the other one. DFS. Oh yeah, I guess you could think of it like a DFS because, you can go depth first search. Okay, so it'll take, I'm thinking at every step it'll probably take a value and candidates. I guess we'll say target. Well, we'll say candidates and target. So same thing as this. We return a list of lists. Okay. So results like that. Okay, so we want to say, and then we also need like the current value as well, or like current sum. So if value is equal to target, then let's print and we also probably want candidates, but also like our answer so far. So nums, like the nums that we've chosen. So we could say nums. So nums equals target. So this will be one combination, and then we would just say res.append a copy of nums like that. Okay, if the value is greater than the target, then that means we don't need to do anything, so we can just like return out. Okay, and otherwise, so if it's less than target, then we want to say I equals 0 while I is less than length of candidates. So the remaining numbers, we want to call DFS again with, so we know the value is going to be equal to the value plus candidates of I, so the one that we choose, and then nums dot append candidates of I. Okay, so the value, nums, and then candidates will be, so candidates, up until I, plus candidates from I onward. So essentially what I want to do is, like, if I have a list of these numbers, and let's say I want to get rid of 4. So if this is called like a list like that, what I want is to return 1, 2, 3, 5. So programmatically, I think you can say, so this equals up until I, if let's say I equals 3, right? So if you do it like this, it would give you 1, 2, 3, and then a list at I guess I plus 1 would give you 5. So I'd want it like this. My only thing is, so if I have two lists, like L1 is 1, 2, 3, and L2 equals 4, 5, 6. If I print L1 plus L2, will that concatenate the lists? It's just what I want to check real quick. Let's comment all that out. Okay, yeah, that does work. I don't know if there's a better way to do that. I mean, we could pop, I guess we could, yeah, there actually is a better way to do that. We can just pop that index out of the list. So it would be candidates dot pop I. So we just remove the ith element from the candidates consideration because we can no longer use it. So here when I equals 0, we pop that, and that is the new candidates list, essentially. Okay. So, and then target remains the same, like that. So we're going to call it for each one. Okay, so I'm just going to see what this looks like. So we'll say basically nums. We'll just kind of see what this does or what errors I get. Output was none. Can I say that? It's a list of integers, right? Oh, I also never call it. So the initial values, so value will be 0, nums will be empty list, candidates, and target will be target. Okay, what's, oh, I'm returning there. That's why. Sorry about that. Okay. Let's see what that does. No length. You can't take length of candidates. Candidates should be a list of integers. But it says okay. Is it printing nums? Equals none. Oh, I see. I'm sending just a popped value. So what I could do is pop the value and then add it back. But I think honestly the other way might be better. So candidates up until I, which is not included, plus candidates of I plus 1, like that. Same complexity, I believe. None type has no attribute append. Okay, so nums is an empty list. Nums. So that is the second argument. Oh. So same thing, kinda. So can I just say nums plus candidates of I like this? Okay, I don't expect this to give me the right answer. I just want to see what it's outputting here. Okay. So it appears to be in the same spots. Also, so target is 8. So there's nothing here that's like 4 2s, for instance. So it looks like these are good. Oh man, this was in combination sum too. I forget how the easiest way to make this unique. But honestly, yeah, that looks pretty good. So I just have to make sure it doesn't count the same things twice. Okay, I'm gonna remind myself what I did for the first one. Honestly, I feel like I didn't even. Yeah, I did sorted, and then I said if it's not in there. I remember I looked up the solution afterwards, and there was a different way to do it. I think it might be algorithmic. So in this case, if we pick a 2, and here if we pick a 9, that's the same solution. What is nums? Nums I'm just making, right? So I could just make nums a set, right? Like if I pass empty set and I put in a copy. Oh, but you can't. I don't think this will work, right? You can't. I think I did this last time too, actually. So if I have a set, something like this, and I have a list. Can I say a list equals list of a set, or no? I think you cannot. Oh, it works. Well, if I could use this, maybe it's the other way around. You can't. it seems to be working. I forget what I was running into then, but it was something to do with that, like a set wasn't, I forget. So either way, what I'm thinking I could do is, oh, yeah, I remember. Yeah, that's fine, but when you have 2D, because it'll just add the same set. Hmm. I mean, I could do what I did before and say, like, if sorted nums.copy not in results, then add sorted nums.copy, and that will probably work. Yeah, that should work. Okay, so that works. But there's some other way, there's some better way to do it. Yeah, so I think I'm gonna probably call the video here, because I don't know how else I could do it. I mean, we'll see. So if we have 0 and then you select 2 and then you select 9, that's the same thing as selecting 9. Like if we select 9 and then select 2. But so this both equals 11. But if I also have, let's say, a 10 and a 1, we want, even though it still equals 11, we want to keep that set of numbers, that combination. So I wonder if there's a way to somehow know. I mean, maybe I could have something called like explored, which is an empty set. And you could say if a set of nums is in explore, then you can just exit. Otherwise, explore.add. So it'd be like a set of sets. Yeah, this is what I was getting. So explore.add. So I don't think you can have a set of sets because you can't hash a set into a hash set. Yeah, that was a problem. You can't have a set of sets. I think it had something to do with just the way that you call the function. Either way, I mean, this doesn't really add, because the recommended time complexity is 2 power n. So just sorting something, I think mine is n log n times 2 power n. So it's not that much worse, but yeah, okay. So I'll look at some solutions and try to remember how to do it next time. Because if you take out this part and you just say res.append nums.copy like this, what it does is it gives every possible combination, but this says yes, right here. The solution set must not contain duplicate combinations. So for instance, 224 and 242 is a duplicate combination. So yeah, I'm happy with this way, but I feel like I should know the kind of standard way of doing it. I'm happy I was able to get it relatively quickly. So yeah, that's call it there for day 20, and I'll be back tomorrow for day 21. Thank you very much for watching.